In a small harbor on the south coast of Shikoku, someone spent 2 centuries writing down how deep the water was. Muratsu, a stone quay, a few hundred meters of sheltered water, boats that needed to know whether they would ground at low tide. The entries are ordinary, depth at the mooring, year after year, kept in part by a merchant family called Kubono. Those numbers are the reason a modern government tells 100 million people to expect the worst earthquake of their lives.
Pull back from the quay. Out past the breakwater, past the horizon, there is a slab of seafloor most people have never heard of, and it is disappearing. The Philippine Sea Plate is unusual among the world's tectonic plates because it is almost entirely ringed by convergent boundaries. It is not spreading anywhere. It is being consumed on nearly every side at once. Down the Ryukyu Trench to the west, down the Izu-Bonin and Mariana Trenches to the east, and to the north, beneath the Japanese home islands, along a shallow depression called the Nankai Trough. The speed is unremarkable, about 4 centimeters a year, roughly the rate a fingernail grows. What matters is the angle. The seafloor going down at Nankai formed in a back arc basin between about 26 and 15 million years ago. It is young, and young crust is warm, and warm crust does not want to sink, so it goes in almost flat, just over 3 degrees across the first 50 kilometers, which means the fault plane runs under the coastline itself.
Almost nowhere on Earth has a written record of a subduction zone this long. The Nankai list begins in the year 684 with an earthquake noted in the Nihon Shoki, the oldest chronicle Japan possesses, which describes land in Tosa dropping beneath the sea. After that, 887, the 1090s, 1361, 1498, 1605, 1707, 1854, then 1944 and 1946. 9 cycles, more or less, across 1,300 years, with gaps running from about 90 years to about 270, and a habit stranger than the list itself. The trough is divided into segments, and the segments do not always go together. In December 1854, the eastern half ruptured at around 9 in the morning. The western half ruptured about 31 hours later, long enough for people on the far coast to learn that something terrible had happened, and nowhere near long enough to matter. In 1944, the eastern segment went. The western one waited 2 years and 2 weeks. Then there is 1707. On the 28th of October that year, as far as anyone can reconstruct, every segment of the Nankai Trough let go at once. It is the only time in the written record that appears to have happened. The Hōei earthquake. Magnitude estimates start around 8.6 and run higher, and it stood as the largest earthquake in Japanese history until 2011. 49 days later, on the 16th of December, Mount Fuji opened a vent on its southeast flank and erupted for 16 days. Ash fell on Edo, 100 kilometers away. The scar is still there, a raw notch below the summit called the Hōei crater, and you can see it from the Tokyo side on a clear morning. You have probably looked straight at it in a photograph without knowing what it was. The connection between the two events is not folklore. A 2012 study modeled the earthquake's stress change squeezing Fuji's magma chambers, but it remains a proposed mechanism, not a settled one. Fuji has not erupted since. Which brings us back to the harbor. Every time the Nankai Fault ruptures, the tip of the Muroto Peninsula jumps upward. Between ruptures, it sinks back down, slowly, a few millimeters a year, and the water at the quay deepens. So the depth of one small fishing harbor is an accidental record of a fault, kept by people who only wanted to know whether a boat would touch bottom. In 1980, the seismologist Kunihiko Shimazaki and a colleague published a model built on exactly this kind of evidence. The idea is elegant. The bigger the jump, the longer until the next one. Time proportional to the slip that came before. Apply it to Murotsu, where uplift is recorded for 3 earthquakes, 1707, 1854, and 1946, and a harbor ledger becomes a countdown. That is where Japan's famous number comes from, not from a network of instruments on the seafloor, from 3 data points and a stack of Edo period paper.
Now the problem. 3 data points is not many. The 1707 uplift at Murotsu has been re-examined against the surviving harbour records and the Kubono family papers, which run from the 1640s onward, and the answer is not a number. It is a range, somewhere between roughly 1.4 and 2.4 meters, a full meter of uncertainty sitting at the front of the calculation. The ground disagrees too. Modern instruments measure that coast sinking at about 5 to 7 millimeters a year, roughly half the rate the model requires. And the approach has failed in the open before. At Parkfield in California, a stretch of the San Andreas produced moderate earthquakes at almost metronomic intervals, and in 1985, a panel of scientists put a 95% chance on the next one arriving by 1993. It arrived in 2004. Faults are not clocks. They do not reset cleanly. The word overdue carries an assumption the evidence does not actually support.
So here is the odd position Japan now occupies. In January 2025, the government's Earthquake Research Committee raised its headline figure for a magnitude 8 to 9 rupture within 30 years to about 80%. Then, later that year, it did something a national forecasting body almost never does. It printed 2 answers side by side. Using the method built on the Murotsu uplift data, roughly 60 to 90% or higher. Using the standard method, the same committee applies to every other fault in the country, 20 to 50%. Same trench, same panel, same document. Both figures land in the highest hazard rank, which begins at 26%. So the practical advice does not change at all. But the candor is unusual, and it tells you something the headlines flatten. The disagreement is not scientists versus skeptics. It is inside the science, on the page, unresolved.
None of that changes the arithmetic on the coast. In March 2025, the Cabinet Office published a revised worst case for a magnitude 9 rupture running from Shizuoka to Miyazaki. Up to 298,000 dead. Of those, 215,000 from water. About 73,000 crushed in buildings, 9,000 in fires. Economic damage of 292 trillion yen. And one line that matters more than any of the totals. In Shizuoka, Mie, Wakayama, Tokushima, and Kōchi, a meter of water is expected ashore within 5 minutes. Not the 30-odd minutes people had in parts of Tohoku in 2011. 5. In places, the modeled run-up reaches 30 meters. This plate has done it before, along its northern edge, where the Sagami Trough ruptured in 1923, and somewhere between 105,000 and 140,000 people died in Tokyo and Yokohama, most of them in the firestorms afterwards. And the grim detail in the 2025 report is this. 12 years of preparation cut the projected death toll by less than 10%.
There is one more thing worth knowing, and it gets the least attention. Nobody has ever touched this fault. From October 2018 to March 2019, the Japanese drilling vessel Chikuyu held position over the trough off the Kii Peninsula, trying to put a borehole through the plate boundary and bring back a piece of it. The target was 5,200 meters below the seabed. The hole kept collapsing. They stopped at 3,262 meters, still the deepest hole ever drilled from a scientific ocean vessel, and still nowhere near. The megathrust that Japan builds its entire national disaster plan around has never been sampled. Everything we claim about it, we infer from outside. From seismic waves, from satellite positioning on the coastline, from tsunami sand buried in coastal marshes, from a family's notes about the depth of a harbor. In August 2024, after a magnitude 7.1 at the southwestern end of the zone,
Japan issued the first megaquake advisory in its history and held it for a week. Nothing followed. That is not the same as nothing happening.
Noctigraph reads the papers before it writes the script. That is slower, and it sometimes means the honest answer is that nobody knows yet. If that kind of not knowing is something you find worth sitting with, there is more of it here. The harbor at Morotsu is still being measured. Somebody is still writing the number down.